let's take another example from mathematics.
Okay.
What is this?
Approximately. Square.
Square.
Yeah.
Yeah. And what is this?
That's a rectangle.
Okay. Is this a square?
No, of course not.
So it's not a square. Is this a rectangle?
No, that's a square, not a rectangle.
So you're saying this is not a rectangle?
No. So like if you go to a room and I say, bring me a rectangular square, rectangular table.
Yeah, you won't get the
me-
square one.
Yeah.
But can't you say that's a squished rectangle?
Squished, you mean a rectangle that is kind of squished like this?
Yeah.
No, no, once it is squished and the sides are equal, then it becomes a square, not a rectangle.
Yeah, because if you bend this over, say, a little bit,
Yeah.
if you make this, then it's squished a little bit on one direction.
That's not rectangle
It's
anymore.
no longer a rectangle.
Yeah.
No, the squishing, if you say it's in a specific way.
But
That's the-
what if I squish like this?
No.
On the
No,
edges?
no, no,
Yeah.
no, no.
So you won't say this is a square, right?
No,
Or rectangle even.
no, it has to be squished in such a way.
Yeah,
That-
but it's
yeah.
squished, but then it doesn't remain a
If you change
rectangle.
it, if you change it, it is not a rectangle.
Okay.
Change it in a particular way. Yeah.
But there's something that's similar about those, so
Yeah, and I read in textbooks saying that this is a rectangle.
yeah.
Right?
Yes. And I've also heard that if you draw two parallel lines like that and two parallel lines this is a parallelogram.
Ah.
And the rectangle is a parallelogram. To me, it's kind of strange because this is a parallelogram,
And that's a rectangle.
that's a rectangle, this is not a parallelogram.
But that's just a difference in the shape of the direction of the lines. That's still a rectangle. I
This-
mean,
you
and
can
that's
this-
still yeah, that's
So
a
are you saying,
parallelogram.
but are you saying this is a rectangle?
No, this is not a rectangle, but
Why is
that's a
that not a
parallelogram.
rectangle? Why is that not a rectangle?
Okay, one way of figuring out is to define these things.
Yeah.
So there are two ways that we are thinking about it. In one case, you're saying a square is a rectangle.
And there are other types of rectangles.
Other types of rectangles. A rectangle is a parallelogram. And there are other kinds of parallelograms. And the parallelogram is a quadrilateral. And there are other kinds of parallelograms.
But then can
Other
you
kinds
say
of
that
quadrilaterals.
a quadrilateral is a type of polygon?
Quadrilateral is a polygon. Everybody would agree on that. There are many different types of polygons, and quadrilateral is one of the types of polygons.
Okay, let me give the, so this is polygon.
Polygon, yeah. So that means that a square is a polygon.
Yeah.
Right?
Let's try by another classification. Is your polygon. Let's assume everyone
Okay.
accepts this. And then you have square, rectangle,
So then a square is not a rectangle.
no, and a parallelogram, and a quadrilateral.
Yeah. So that means they're all distinct.
Yeah.
A rectangle is
so
not a parallelogram.
quadrilateral would be something like this, is a
Mhm.
quadrilateral. Because it's neither of the others.
Yeah. So this is not a quadrilateral.
No.
This is not a quadrilateral.
No.
This is not a quadrilateral.
But
Okay.
but what is a parallelogram? Because to me, rectangles and squares, those pictures look like parallelograms.
So we have these two possibilities, right?
Yeah.
You want that.
Yes.
This is what you want.
Yeah.
Well, let's figure out.
Yeah. So what is a polygon over here? What is a polygon?
Wait, let me write that down.
Yeah.
Let me erase this. So are we going to define polygon first?
Yeah.
What is a polygon?
Yes. Okay. But let's first say what's at stake. Tara wants us to have this classification.
Yeah.
She wants quadrilaterals parallelograms to be quadrilaterals, rectangles to be parallelograms,
Square
squares
to be rectangle. Yeah. And
Mo
there
wants this one, where squares, rectangles, parallelograms, and quadrilaterals
are
distinct from each other, but all are types of polygons.
polygons. How do you make the choice? Well, let's begin by defining a polygon.
Yeah.
Okay, a polygon is a closed shape composed by and only by straight lines. So that is something that whether you have this definition, this conception, or that conception, that will apply to all of them.
Just quickly, I just wanted to say the importance of saying and only by. Because if you said just composed of straight lines or composed by straight lines, you would say that this is also a polygon.
Right, that will be a polygon because there are straight lines.
There are straight lines and there are other lines.
Yeah.
Right? But when you say only by straight lines, then this is not allowed.
Right. Okay. So now let's define
Quadrilateral here in terms of polygon.
quadrilateral, assuming that a quadrilateral is a polygon.
So
Okay.
you would is a four-sided polygon.
Yeah. Well, that's all you have to say.
What about the definition of a quadrilateral in that system?
No, let's do this first.
Well, let's do
this first. Yeah.
This one's easy.
Yeah, parallelogram
Is a quadrilateral? What kind of quadrilateral is it?
with opposite sides parallel.
Okay. And a rectangle would be a parallelogram.
Rectangle is just a parallelogram with all right angles.
In fact, we could even
one
say
right
just
angle.
one right angle, right?
Yeah.
And you get all the rest.
If one of the angles is a right angle, then it has to be the case that everything else is a right angle.
No. No, they don't all have to be.
If the in a parallelogram, if this angle is like that,
Yeah.
then this will have to be parallel. These two.
But you haven't said anything about
Then this will have to be right
No,
angle.
you haven't said anything about equal sides.
You don't need equal
Oh, I
sides.
see.
Parallel.
Okay,
They're parallel,
right. Okay. If one is a parallelogram and one is a right angle,
All are right.
Yeah.
with a right angle.
Of course, this will need some theorems about quadrilaterals and parallelograms
Yeah.
and so on.
Yeah.
Those theorems will give you the consequence.
Yeah. A square is a rectangle.
With equal sides.
You don't even need to say that. There is the
Adjacent sides are equal is enough. So in the rectangle, if this side and this side are equal, then of course this side and this side will also be equal to these sides.
What's the difference between saying all sides are equal and adjacent sides are equal? Why does
so in fact with one pair of adjacent sides equal.
Yeah.
So in this case, if you wanted to check whether something was a square and you know it's a rectangle, then if you're saying all sides are equal, you have to check this, and this and make sure they're all equal. However, if you say just one pair of adjacent sides equal and you have a rectangle, all you need to do is pick up two sides and check
Two sides.
So it's an easier process to check whether something
fair
is a
enough?
square.
Yeah.
Yeah. Now let's try
This looks like a very simple
Yeah.
situation.
Yeah. So let's see if the same thing happens here.
Mhm.
Okay. So what's a square over here?
Why don't we begin with the quadrilateral?
I'm suggesting we begin with a square. We'll see why in a bit.
Okay.
Okay.
A square is
Okay.
a polygon
Mm-hmm.
with four sides
So you'll write the same thing.
with opposite sides.
It's a four-sided
opposite
polygon.
sides equal.
Oh, with opposite
Sorry,
sides.
no, opposite sides.
With all sides.
With
all sides
opposite,
equal.
opposite sides parallel,
Opposite sides parallel. Okay, that is true.
with a right angle and a pair of adjacent sides being equal.
Oh, that looks pretty complicated.
That's what you wanted.
Well, I was hoping to get that system work, but that system gives me a very complicated definition.
What's a rectangle?
A polygon with 4 sides,
A polygon with 4 sides.
with opposite sides equal and one right angle.
But you should also have adjacent sides not equal.
Yeah.
Because if the adjacent sides are equal,
Then it's
then
a
it will,
square.
we don't want that to be a rectangle.
A square. Oh, okay.
Yeah, we
Right.
don't want a rectangle to be a square.
Right.
Sorry, a square to be a rectangle. Opposite sides parallel.
Adjacent sides not equal.
One angle, yes. Right angle.
It's a very
Adjacent
tiring-
sides not equal, yes. Oh. You don't have space to write. You can write here.
Do you really want to write them all now?
Yeah, we
Obvious.
are.
One more.
No,
At least,
we
no?
need to do both.
Okay.
It's going to get fun.
See, this one's so simple.
I know, but let's see what it takes to do that.
No, hang on. There's something more than just being simple.
Hmm.
Here you see the relationship between these. They're totally unconnected things.
That's right.
But let's go on.
Yeah,
What's a parallelogram?
You have
A
to say
polygon with
polygon with
four
4 sides, with opposite sides parallel, and you have to say no right angles. And adjacent sides not equal.
No, a tilted square is still a parallelogram, isn't it?
No, it should be a what you call a rhombus or a right.
Then
No, over here that's a parallelogram because we don't have rhombus.
We don't have a
Oh,
rhombus.
since we don't have rhombus,
Yeah.
okay, that's fine.
A
But if you
polygon-
also include rhombus there,
Yeah.
then you have to exclude that one.
So, can you repeat the definition?
A
A polygon
is
with
with 4 sides
with
opposite sides
parallel.
Opposite sides parallel.
and no right angle.
And now
And
quadrant.
now, yeah, square.
Quadrilateral is a polygon with 4 sides, with opposite sides not parallel.
No. So this is a polygon. No, sorry, quadrilateral. Opposite sides are
So
parallel.
you have to say
At
make
least
it
one
even
side.
more complicated. At
Yeah.
least one pair of opposite sides not parallel.
Okay.
That should work.
Go.
And with no more than one right angle.
We don't need that.
You don't need that? Sure? Yeah, I guess once you've said not parallel, that's enough.
Mm.
And
That's enough.
so imagine if we added trapezium because this is the
Or if you
trapezium.
have trapezium, then you have to make it more complicated.
Yeah.
And rhombus?
Rhombus.
And rhombus you'll just have to complicate this. You probably won't have to work much on that.
Yeah.
But after that, but trapezium you'll have to edit that further. It's not at least one pair of opposite sides not parallel, no. Then that doesn't differentiate from a trapezium.
You have to say that
No opposite sides are parallel.
no adjacent sides are equal, you have to say that.
Or no pair of opposite sides is parallel also.
Something like that, yeah. Yeah.
So
Okay.
so notice one problem with this versus this was I'm extremely tired.
You are writing these definitions that are too long.
Yeah.
But there is also something else, right? Earlier when Tara said square, we said many of the properties of square follow from other theorems.
Yeah. So notice when you say in a square, the diagonals are equal.
Okay.
And perpendicular to each other.
And but that
Yeah,
doesn't
that
come
comes,
from rectangle. It just says the diagonals are equal, and a rectangle also diagonals are equal.
Equal. So those properties you don't have to stipulate separately for square
In
and
this
rectangle.
system.
Yeah, in
But
this system.
in this system,
Yeah.
if you say if you want to prove that diagonals are equal in
Yeah.
squares, you can't just prove it in rectangles. You have to prove it again for squares.
Right.
If you want to say that the sum of the angles is 4 right angles,
That will follow from
So what you're saying is, anywhere where you have
a theorem about say if you have a
say
theorem about this,
quadrilateral, that will automatically apply
come
to
all the way down.
Yeah.
yeah.
But so back here, if you say the sum of the angles is 4 right angles, you have to prove quadrilateral, parallelogram, square, and rectangle
Okay.
separate.
Okay, this is so what you're saying, any property that is true of this will be inherited by this, and by this.
Yeah.
So this is what they call the logical inheritance.
Yeah.
And we are exploiting the logical inheritance, both here in these definitions
Yeah.
and in the theorems.
Yeah. And actually notice when Tara was defining square and rectangle, she was looking at these definitions
Yeah.
where we were using logical inheritance
copying
and
those things.
copying those things over here.
Yes.
So some cheating was happening.
Yeah. So the technique that we are using in this investigation is when you ask the question, what is a square? And is a square a rectangle? What we are doing is taking many examples, defining these other things,
Yeah.
showing the relationships.
Yeah.
And crucial to this technique seems to be investigation through the use of definitions.
Yeah.
That seems to be extremely important in conceptual inquiry.
Yeah. Now in here we were choosing between two possible definitions for each of
And
these.
showing that one set of definitions is too complicated.
No, it's not just too complicated.
Yeah.
He fails to show the relationship.
That's
between
right,
Yes.
yeah. And one way of showing that the relationships are not shown is by showing the theorems which are true here but not there.
And the fact that there is a relationship is shown by the fact that I could cheat and get these
Yeah,
definitions.
that's
Yeah.
Yeah.
Okay.
Okay, so that gives us a different perspective on conceptual inquiry.